The ionosphere is a region of Earth's atmosphere that is critical for communication and space weather phenomena. Here's an overview of the ionosphere. Location. The ionosphere is located within the thermosphere and extends into the lower part of the exosphere, roughly between 30 kilometers, 19 miles, and 1,000 kilometers, 620 miles, above Earth's surface. Characteristics. The ionosphere is unique because it contains ionized gases, atoms and molecules that have been charged by solar radiation. Solar radiation, particularly ultraviolet, UV, and X-rays from the sun, causes ionization in the ionosphere, which means that high-energy photons knock electrons out of atoms and molecules, creating charged particles, ions and free electrons. Key functions. Radio wave propagation. One of the most important features of the ionosphere is its ability to reflect certain radio waves back to Earth, allowing for long-distance communication. This is particularly important for high-frequency, HF, radio signals, which rely on ionospheric reflection to travel beyond the horizon. Auroras. The ionosphere is responsible for the auroras, northern and southern lights, which are light displays caused by energetic particles from the sun interacting with the ionosphere's ions and electrons. Space weather. The ionosphere is affected by space weather, such as solar storms and solar flares, which can disrupt communication systems, GPS, and even power grids on Earth. These solar activities can increase ionization in the ionosphere, creating disturbances. Satellite communication. The ionosphere affects satellite communication signals, particularly at low Earth orbit, LEO. Variations in ionization can cause signal delays or interference, which is taken into account by engineers designing communication systems. Layer structure. The ionosphere is often subdivided into several regions based on the density of ionization. D layer. The lowest part of the ionosphere, from about 30 to 60 kilometers altitude. It has the lowest ionization levels and mainly absorbs radio waves. E layer. Ranges from around 60 to 90 kilometers altitude. This layer has moderate ionization and is responsible for some radio wave reflection. F layer. The highest ionized region, above 90 kilometers, and it is further divided into F1 and F2 layers. The F2 layer is the most ionized and plays a critical role in radio wave reflection for long-distance communication. Impact on daily life. The ionosphere's effects on radio communication are both beneficial for long-distance communication and challenging due to interference from solar activity. Understanding the ionosphere is essential for improving GPS navigation, satellite communication, and predicting the impact of solar storms. The ionosphere is a dynamic and essential part of Earth's atmosphere that directly influences both our technological systems and our understanding of space weather.